All right, guys, so today we're doing notes 2, 3. This is going to be inequalities application. So it's sort of like combining the last two things we did with what we did in the last section of chapter 1. So we will be using inequalities, things like less than, greater than, less than and equal to, greater than or equal to. And some of these actually have real-world application. So let's go ahead and get started. The first question says, Albert earns $3.50 for each hour he works. If he wants to earn at least $52.50, how many hours must he work? So there's a couple of really important pieces of information in here. The first is Albert earns $3.50 per hour. And he wants to earn at least $52.50. So I'm going to go ahead and calculate how much money he makes per hour, which would be $3.50 per hour. I'm going to call it H. I'm going to write over here that H equals hours. So obviously if I work 10 hours, it'd be $3.50 times 10. Well, he wants to make at least $52.50. So now we kind of have to decide what inequality to use. He wants to earn at least that, so it's going to be equal to as well. But we have to decide, is 52 going to be bigger than what we want, or is it going to be smaller than what we want? We want to make at least that much or more, so we want the number of hours we work times our pay to be greater than or equal to 52.50. Now that's probably the hardest part of these problems, is writing the inequality. You're really going to have to think about what it's saying. Once we do that though, all we have to do is solve. Well, I have $3.50 times H is greater than or equal to 52.50, so to get H by itself, I divide by 350 on both sides. The 350s cancel over here, so I have the number of hours I have to work is going to have to be greater than or equal to 15. And there is our answer. So, you know, if you're working in the future and you want to know how many hours you'll have to work to get a certain amount of money, this would kind of help you. So what this means is Albert must work at least 15 hours. So again, the setup's not that hard, but watch your inequality. Let's look at the next problem. The daily production cost for a skate factory cannot be more than, I'm going to go ahead and underline that, it cannot be more than $5,400. It costs $15 in materials to make each pair of skates, and it costs $900 just to open up for the day. It says how many pairs of skates can be produced under these circumstances. So I'm going to go over here and I'm going to label that P equals the number of pairs of skates. You can use X if it makes you feel more comfortable, but at least I know P for pair of skates. Well, how much does each pair of skates cost? Well, it's $15 each, so 15 times P. But just to open up the doors to make them costs $900, so I'm going to have to add $900 to the cost. Now I know that I can spend $5,400. So again, I have to make sure my inequality is correct. I cannot spend more than $5,400. So 54 needs to be as big as it gets. So I'm going to open toward 54, but I can actually spend that much money, so it's going to be equal to as well. So again, be careful. That's the tricky part. That may be something you need to ask questions about. So now we've solved these problems before. First, I want to move my number to the other side. My goal is to get P by itself. So the 900s cancel out. I have 15P is less than or equal to 4,500. Please be careful with your arithmetic. That is what has been killing people. Now to get P by itself, I have to undo multiplication with division. So I divide by 15. The 15s cancel, leave me P is less than or equal to 300. Now we need to be clear about what that means. That means I can make no more than 300 pairs. If I make more than 300 pairs, I'm going to go over my budget. So once you set it up, again, it's pretty simple. Just be careful when you're setting up the inequality. Let's go to the back page. It says a group of 3 friends went to the movies. after paying for their sodas, after paying for their tickets, they had a total of $10 to spend on refreshments. Sodas cost $1.50 each, and a box of popcorn costs $1.75. How many sodas can they buy if they purchase 2 boxes of popcorn? So we have two things going on here. We have popcorn and we have sodas. So I'm going to go ahead and say that S is my sodas and that P equals popcorn. And luckily for us, they already told us that we're going to be getting 2 popcorns. So let's see if we can set up our inequality. Well, first, I need to know how much each costs. A soda is $1.50, so $1.50 times the number of sodas I buy, plus $1.75 for each package of popcorn. Now, I only have $10. I can't spend more than that. That means 10 has to be bigger, but it can also be equal to. Now, we can do a little bit more legwork here because we know how much popcorn we're going to buy. So I'm going to have $1.50 per soda plus $1.75 times 2 popcorns. That has to be less than or equal to 10. So we can do our multiplication and go to the next step. $1.50s plus 1.75 times 2 is $3.50. That has to be less than or equal to 10. So there's a little legwork to get this started, but now we can solve. The first thing we want to do is move our number. So I'm going to subtract 350 from both sides. Now I have 1.50s is less than or equal to $6.50. Now we've done this multiple times now. We need to divide both sides by $1.50. Sorry if I've kind of run into the next problem there. When I do that, I get that the number of sodas I get has to be less than or equal to 4.33, and that's our answer. Now, you need to understand that that means I can't just buy 5 sodas, and you can't buy 4.33 sodas, so this means I can buy 4 sodas. So it looks like you might have a little change. But again, guys, it's the same basic setup. If you see one that has 2 variables, look at this example and use it to help you. Let's go to the next one. Now this one's a little bit different, but it's actually a little bit easier as far as the end goes. It says on an interstate highway, the maximum speed is 70 miles per hour and the minimum speed is 45 miles per hour. If X represents speed, write an inequality to express this condition. Well, guys, 45 miles an hour is the absolute lowest speed we can go. 70 is the highest. And I know we can speed and we can break the law, but we're not doing that in this problem. Our speed needs to be in between those. It doesn't need to be smaller than 45, and it can't be bigger than 70. So I'm going to start with the 70 part. I need 70 to be bigger than my X. So I'm going to put less than, but it can actually be 70 also, so it's going to be equal to. Now, between the 45 and X, I need X to be bigger than 45, but it can also be equal to it. Since X is by itself, that's our expression. So there you go. Let's finish up the last problem. Now, before we started, I want to talk about averaging real quick. If I had 6 grades, to find the average of those grades, I'd add all 6 of them up and divide it by 6, the number of grades I have. This kind of works the same way. Kevin's history grade will be determined by the average of 4 tests. He received a 76, an 85, and a 74 on the first 3 tests. He needs to get an average of between 80 and 89 to receive a B. What are the possible scores he can make on the 4th test to receive a B in history? Now, you're going to see this question fairly regularly throughout the year. You really need to pay attention to how we set it up. So I'm going to start by just trying to find an average. I know one test was 76, another test was 85, and the 3rd test was a 74. But we don't know what the 4th test is. That's our variable. I'm going to call it X. Now, if we were going to find an average, we'd have to divide those by the number of tests, which is 4. Now, that's not all we have to do here. I need it to be between 2 values. The lowest value I want it to be is 80, and it can be exactly 80, so I'm going to put that's less than or equal to 80. The highest to get a B would be 89, but it can also be an 89, so it's also equal to. Now we just need to solve. let's clean it up just a little bit before we finish. I'm not going to change the 80 yet. 80 is less than or equal to. What I do want to do is add my like terms. 76 plus 85 plus 74, I got to be 235. But I couldn't add the x to it because they're not like terms. That's still divided by 4, and it's less than or equal to 89. Now, you don't have to do that step first, but I think it's a good place to start. Now, remember, if we have an inequality that's in between two values, we need to work from the middle out. And I want to clear that fraction so I don't have 4 as a denominator. So I'm going to multiply the middle by 4, but I'm also going to multiply both of the outside values by 4 as well. 4 times 80, and I'm going to move over here, sorry, is 320, is less than or equal to, the 4's canceled, so I have 235 plus x is less than or equal to 89 times 4 is 356. Now we need to get x by itself in the middle. The way to move that number out of there is by subtracting 235. But I got to do it to all three sides. 320 minus 235 is 85, is less than or equal to all that's left in the middle is x, is less than or equal to 121. So what this means is that if I want to get a B, I have to at least make an 85, and if I want to get an 89, I'd have to make 121. So it must be between those numbers, but obviously we can't always get over 100 on papers unless there's a bonus. So we need to make somewhere between an 85 and 100. Guys, use your notes when you're working on your homework. That's the best way to get better. A lot of your homework problems are similar to these notes. Use them. If you have questions, let me know. Good luck.